If you've been following the tech world, you've probably heard one phrase over and over, the AI arms race. But the big question we're asking today is the finish line anywhere in sight? Or are we just getting started? Hi everyone, I'm Jerry Chen from Thrust IQ, and today we'll be looking at the AI arms race. Judging from the latest insights from industry experts and looking at what giants like NVIDIA and TSMC are doing, the answer is pretty clear. This war, it's still heating up. But here's the thing, the battlefield is changing. It's no longer just about who has the best AI model, it's about who can actually get the chips to run them. You see, for a while now, everyone has been pointing fingers at TSMC, saying their CoWoS advanced packaging capacity is the bottleneck. And sure, TSMC has been expanding like crazy, literally doubling their capacity from 30,000 to nearly 70,000 wafers recently. But here's the new problem emerging for next year, and it's a big one. It turns out we aren't just running out of packaging capacity anymore, we are running out of the actual 3nm wafers. Think about it. Next year, NVIDIA's Rubin, Google's TPU, Amazon's Trainium, AMD, Meta, everyone is moving their massive chips to the 3nm process at the same time. So the question is, even if TSMC expands their packaging, if they can't make enough of the base chips, what then? And this leads to the future tech that's going to solve this, because this is fascinating. Industry insiders are buzzing about something called CoPoS, or panel-level packaging. Right now, chips are cut from round wafers, but as chips get bigger, like the upcoming Rubin Ultra, using a round wafer wastes a ton of space. Experts estimate you might only get 4 chips from one wafer. But if you switch to a rectangular panel, you can cut 12 chips. That is huge efficiency. But don't get too excited just yet. This tech won't be ready for mass production until about 2028. Why? Because the equipment ecosystem just isn't there yet. TSMC has to basically force equipment makers to invent new machines to handle these panels, and that takes time, at least 2 years of testing and mini lines. Lastly, moving away from the chips themselves, there is another hidden cost to this AI boom that we need to talk about. We are calling it AI inflation. First, memory prices. They are skyrocketing. Not just high-end HBM for AI, but even standard memory for general servers is bouncing back because big players like Meta and Microsoft are upgrading their traditional infrastructure too. And get this, hard drives are in such short supply that companies are being forced to buy SSDs instead, driving up flash memory prices. But the real inflation? It's electricity. Data centers are hungry, and while they might only use 4 to 5% of total power now, they have the money to pay a premium for electricity, which could drive up costs for everyone else, from EV manufacturers to your monthly utility bill. This power problem is actually creating a new investment opportunity though. As chips get more powerful, pushing toward 130 kilowatts or even a megawatt per rack, traditional power systems can't cope. The current is just too high. It's dangerous. So the industry is shifting to high voltage direct current, or HVDC. We're talking about moving from 54 volts up to 800 volts to keep things safe and efficient. So what's the takeaway here? The experts agree. As long as the big players keep spending, the supply chain, from TSMC to power management companies, is going to stay very, very busy. Let me know in the comments if you think this AI inflation is going to hit your wallet next. Thanks for watching, and I'll see you in the next one.